What was that? Oh, mine just did the same thing. Huh, interesting. Okay, yeah, 'cause mine says it's published here, so yeah, give it a refresh. Hey, you got it? Cool. Nope, you're good. We're still potentially waiting for two more people, hopefully. Um, so what's that? Well, if they actually are, come on here, but then we are. But we'll give them a minute or two. So welcome to CAD 2. We're gonna be doing kind of a fun project this quarter. So you guys are all gonna build a Rube Goldberg machine. Does everybody know what that is? Has everybody kind of heard of those? So basically, a Rube Goldberg machine is a machine that does something pointless but kind of fun. So basically, it's going to be made up of parts that you design in CAD and we 3D print, and it can do all kinds of stuff. So it's a Rube Goldberg machine is pretty like it's pretty much anything. It's random. It does random silly stuff, like it knocks over dominoes or it pops balloons, or it makes a gear spin that moves an arm that like you can have it do anything you want. So the idea is going to be each week each of you is going to design a part in SolidWorks, and then we're gonna go over it, make sure that it's something that's gonna work, and then we're gonna 3D print it, and you're gonna start incorporating it into your machine. Um, so by the end of the quarter, you should have a big Rube Goldberg machine that does some random stuff. So yeah, there's a link for something cool. Nice. Hmm. Nice. Cool. So the way we're gonna organize this, I think what I'm gonna do, because there's 8 of you in the class, is we're gonna split into 2 groups, and each group is gonna do a machine. But within each of those groups, each of you is gonna have like a distinctive section of the machine. So you're gonna say your section of the machine might um, like roll a marble down a ramp, and then the marble knocks over some dominoes, and then the dominoes run into something that swings around and pops a balloon, or whatever you want it to do. But so your section is going to be as complicated as you want, basically, but it's got to be something that you can complete within the quarter. So we're going to have 8 weeks. You're going to 3D print 8 parts during those weeks, and each um, each section can also incorporate parts that are purchased, or that you just find, but they have to be something simple and easy. Like you can, if you want to use like marbles or dominoes or balloons, you can't really 3D print those. I guess you could 3D print dominoes, but um, if you wanted to, incorporate some of those, you just have to give you know, a, you just have to let me know, like, hey, I'm going to use this. I have it, or, we need to source it, and, this is what it's going to do. So it's got to be something that you can't 3D print, and that's going to be in addition to the part you come up with each week. So you can't like replace the part that you're supposed to design with something that you're just going to source. You've got to design something every week. But the thing that's going to be cool about this is like you're going to get a lot of practice just designing parts and then making them work and 3D printing them, which I don't know how many of you have 3D printed something before, but um, it can be really finicky. If you design something upside down, like the printer, it's almost like hot gun glue. It like lays it down, but if it has nothing to rest on, it's just gonna droop all over the place and make a big mess. So you kind of have to consciously design your part with that in mind, that it's gonna have to be 3D printed. So the other thing too is that um, you're gonna have to work on like you're gonna want to work on like your speed with designing stuff. So because you're gonna be designing a whole bunch of things, you're you're gonna get a lot of practice with like drawing parts and um you know adding features and changing things so that they turn out how you want them. You're probably gonna design and redesign things a couple of times. Um, so so that's gonna be. Let's actually go to the assignments page here. Everyone can see my screen, right? Oh, yeah, it's in Twitch. So I'm streaming. Let's see if I can find my link here. Yeah, here. Let me get you a link real quick. 1 second. Nice. All right. And I'm gonna send my link in the room there. So there you go. So you should be able to watch me on there. Got it? Cool. All right. So in the assignments section on Canvas, hopefully everybody's able to pull that up now, but here's my screen. So here's actually another video of um, a 3D printed Rube Goldberg machine. I'll go ahead and just click that real quick. And it's pretty loud. The music is kind of obnoxious. Turn that off. But basically, these guys 3D printed a Rube Goldberg machine, and you can see it's just doing different stuff. So like it's not doing something specific. It's just kind of moving things around, and the whole thing is a process from start to end. So like each section makes the next section happen is pretty much what you want it to do. You can also see they're doing stuff like there's a part of it where like they break some glasses, and there's a part of it where they throw confetti everywhere. And you guys are totally welcome to do stuff like that. It might be kind of fun, to break some stuff or make a mess. And that's totally fine. We can make room in the lab for you guys to do that if that's part of your machine. But I would recommend that you put the messy stuff at the end of your machine, because as you're testing it, you're gonna run through it until something doesn't work, right? And then you're gonna fix it. You're gonna try to fix it and start over, and you're gonna end up running through like the first couple stages of your machine over and over and over again. So if you're putting a broken glass at the beginning, you're gonna have a lot of broken glass to pick up after testing for a while. and you're going to run out of glasses to break. So you want to put something messy like that, or like confetti or whatever, at the very end of your machine, just to kind of make it easier on yourself a little bit. Um, does that all make sense? Cool. All right. Yeah. That'd be kind of annoying. Um, yeah, so a couple of things this quarter. It's going to be a lot more beneficial to you than it was in CAD 1 to like actually come in and try to work together. So, again, I reiterate this every couple of weeks or so, but just, and I'm sure Carl and Jason do too, but make sure if you come in, you check in and you wear your mask and you social distance and all that stuff. But when you're here, in person, you can work together, you can test things. So you're going to be coming in and spending time in the lab a little bit more. You're also welcome to come here and be in the classroom during my class period if you want to. Um, if it helps you to like be there with a student in your group and you can talk and brainstorm. We're going to spend a lot of the class time uh, talking about your project versus just me lecturing. Um, so so it's going to be probably a good idea sometimes for you to be able to like have that back and forth during class. I'm not going to be taking attendance this quarter. If you're not here, you can always watch the lecture afterwards. But the really important thing is that you get your assignments turned in, you work with your group, and you make your machine work at the end. So if you're not showing up to class at all, if you're not engaging, like you're just going to be screwing yourself. It's not going to be, it's not going to be an issue of like you lose points for attendance. It's you're going to lose out other places. So as long as you're putting in the effort and paying attention and designing your machine and working with your group, like I don't care too much if you're here or not. It's to your benefit to be here, but it's kind of I guess basically you're adults. I'm not gonna say you have to be here. Like if you want to be here, you'll be here. So yeah, we won't be taking attendance this quarter. But yeah. So I guess any questions so far? So that's the next thing. I guess we're gonna do two groups of four, I think, since there are eight of you total. And you guys can split up however you want. So there's gonna be two machines, and each one is gonna have four people working on it. So you're gonna have four sections basically on each machine. And each of you is totally responsible for your section of the machine. The only thing that you need to worry about with the group is like basically you're going to be like in your group you're going to be one, two, three, and four, and so the sections are going to be sequential. And at the end of your section you're going to have some kind of a handoff to the next person's section. So like for instance, because these machines, everything is in stages, right? Like, so something falls over, it hits something else, that knocks a marble down a ramp, the marble falls into a gear and spins it. Your section is going to have to interface with the next person's section at the end. So, like, say your last thing is you roll a marble down a ramp, the next person's section is going to have some way to catch that marble and use that energy to move their section. So, and then, you're also going to have to consider what's at the beginning of your section. So you're going to have to talk to the person before and after you on the machine, basically, about what you're doing. Does that make sense? Yeah, I mean, however you want to do it, it's totally up to you. So, like, you could also, it doesn't have to be an object moves from one section to the next. It could be like an arm swings and hits something in the next person's section, and that starts the motion in their section. It can be any type of handoff you want. You just have to make sure you coordinate that handoff so it works. And you guys can decide. I mean, it's up to you who you work with and who goes where on the machine. I think it's better for you guys to figure out what makes the most sense based on who's here when and when you can meet and who you're used to working with. That makes more sense to me than just randomly assigning groups. So, if you guys want to kind of hash that out. Um, so today, oh, go ahead. Yeah, totally. So you're gonna want to like sketch up what you're doing. You're gonna want to have a rough sketch of what your machine is gonna do, and of course that can change. What you decide now is not set in stone for the whole quarter. So if you decide like, oh, I was gonna use gears here, but I think it would work better to do something else, later on down the road. You can always change it. But I do want you guys to like kind of come up with a rough sketch of what your machine is going to do as soon as possible, so that so that you have something to start with. And you're not going to design anything in CAD until you've kind of come up with like, here's what I want my machine to do. So you start big and work your way down to the individual components, basically. So by the end of class today, I kind of just want to give you guys room to talk and kind of figure this stuff out. Um, and by the end of class today, I'm hoping you can all maybe uh, come up with like a quick sketch of what you want to do. If you all want to kind of discuss, who's going to be in what group, um, and how you're gonna handle that. Is everyone cool with that? Cool. All right. Yeah. Okay. So the 3D printer we have here is like, uh, you don't want to go bigger than like 8 by 8 inches, as far as like width and depth, and then height wise, you can probably go about the same. It's kind of a big box, so, um, I'll actually get exact numbers for you guys on like what your size limits are for individual parts, but as long as you stay within like, 8 to 10 inches on each plane, you should be fine. So, yeah, it's been a minute since I used it, and I don't remember trying to print anything that was too big for it, but we everything I always did was pretty small. So, um, yeah. All right. So, let's see. This is so much easier in like a classroom because I can be like, okay, everybody talk to each other. But, um, let's see. Yeah. Okay. Cool. All right. Cool. You guys coming up with a plan? I don't see him. Cyrus, to answer your questions, yeah, so I'll give you your actual assignment for the week at the end of class today, but it's basically going to be you're going to want to start designing your first part. Um, so you'll want to, you want to kind of have an idea of your section of your machine, like what it's going to do, so that you can do that. And you're just going to design one part this week. You're going to come up with like the justification for why you're going to use that part and why it makes sense to 3D print it for the machine and not like buy it or source it from somewhere else. And then we're going to review your part and you're going to 3D print it once we decide that it's printable. Um, so, does that answer your question, kind of? Cool. So, when you guys, once you come up with like kind of a idea of what your machine is gonna do, if you want to like make a sketch and you can just take a photo of it and post it in the chat, um, that way we can all take a look and we all have an idea of who's doing what. And also maybe post in the chat once you've got it hammered out, post like this is who's in my group. This is gonna be my stage of the machine. So like just say 1, 2, 3, or 4. Does that make sense? Hmm. Um, so it depends on what it's doing. So like, actually I haven't watched the video in the chat yet. So let me, ooh, shoot. Okay, yeah, there's like little dominoes and stuff. Um, yeah, so it can be either one. So like in the video that um is posted in Canvas there, you can see like there's gears and there's little levers that get flipped one way to the other. And there's a lot of stuff that's connected and there's also stuff that's not connected. And you can do either one. You can do both in the same machine. Um, so uh you can have a bunch of dominoes knock each other over and those are all individual separate pieces. You can also like it shows a ball rolling down a ramp here. Obviously the ramp is going to be a bunch of pieces that are connected together kind of structurally to support that ball as it rolls down. um but uh yeah, it can be either one pretty much. You can and you're going to have multiple things happening in each stage. So like um it's going to be you're going to have a chance to do either or both. Um I'm not going to give you a size requirement per se, but like with 4 people each making a section that, encompasses multiple parts, you're going to want a good amount of space. Like and we've got, we can make space in the lab for you to set it up. So, it's not going to have like a size requirement, but it's not going to, be like it's not going to fit in a cardboard box. It's not like you're not going to fit it all within a couple of feet. It's going to be fairly big by the time you're done. But you're gonna want to, you're kind of gonna want to scale it. So like the videos that we've seen here, like, um, they have gears that are like a few inches in diameter. They have dominoes, but like the dominoes are obviously big enough to knock things over and start the next phase. Um, you're gonna have ramps, and like marbles are little, but they're somewhat heavy for their size, so they're gonna, you can use marbles, but they're gonna they're gonna take up some space too. They're gonna have to roll down a long enough ramp to get enough momentum to knock into something hard enough to do the next thing. Does that kind of make sense? So, so yeah, there's no size requirement, but you're gonna want to scale it so that things work, basically. Yep. It's it's the second message in the chat. Hmm. Yeah. Hmm. Hmm. Yeah. 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 So, and like, so the other thing too is like you're gonna be designing a unique part of the machine each week. Um, so like, say you want to, for instance, you want to have a stage that is just dominoes knocking each other over, and you say, I don't know why you would do this, but you say, I want to 3D print all the dominoes. Um, you can't like just design a rectangle and say like that's my whole project for the week, it's got to have a, what was that? Oh, you're good. Um, right. Yeah. So yeah, it's gonna have to be a reasonable degree of complexity. Um, and as long as it's not, you turn in a domino each week, like, I mean, you're gonna want to like come up with a unique, distinctive part that does something that isn't something you can just, you know, get out of your junk drawer in the kitchen. Um, so, uh huh. Yep. Can you use fire? Oh boy. I would say probably not, just because it's winter and you're going to be working inside the building. Um, and I don't want to get in trouble. What's up? Yeah, you could do a fuse, I think, as long as nothing blows up at the end. Um, yeah, I think that'd be all right. Yeah, yeah, that sounds cool. I like it. I'm kind of, uh, I would say nothing that could be spilled on the floor and start a conflagration. Um, I like fire as much as, anybody, but uh, and I don't want to have to be the safety person here, but that does sound fun. But I think it's probably better to err on the side of caution with uh, flammable substances. Ew. Yeah. So let's say like explosives are all right as long as they can't cause damage to school property. So, like, I don't want you burning a hole in the floor, no sulfuric acid. Um, no, like, uh, no big explosions, but I think a fuse would be okay as long as you set it up in such a way that, like, when the fuse is burning, it's not like resting on the floor and making marks that we can't get out or anything like that. Just let's just try and be careful and err on the side of caution. Um, but I'm not gonna say absolutely no anything with sparks. Like that's fun. It's supposed to be fun. So yeah, that's fine. Um, we'll have to like make a good showing of wearing our hearing protection if people are watching. But oh yeah. Mhm. Yeah, so at the end you're going to want to do a YouTube video of your your machine, the whole thing running. I think let's see. I don't know if we have like I think um so the final assembly is you're going to have to so you're each going to turn in an assembly at the end, like a SolidWorks assembly file of your section. And it's fine if like the parts you purchased are missing or not in the assembly, as long as everything that you 3D printed is in there. And then at the very end, you're gonna get together with your teammates and you're all gonna put your assemblies together into one big assembly and turn that in. I also would like at the end, let's see, we do have a final demonstration assignment here. I think what we're gonna do for that is I'm gonna have you make a YouTube video of the whole machine going and turn that in. Like just turn in the link to the video. But I'll also be in the lab. I'll want to see it go in person too. So that'll be part of the assignment is like seeing your final machine in action. So the way that each week's assignment is going to work, so we've got these practice exercises here. I haven't published any yet, but this is basically for, uh, if you feel like, you should all be fairly fluent in the basics of SolidWorks at this point. You should be able to make a 3D part, um, and assemble things. So this is really going to be a lot of practice and going into more advanced stuff as needed. But there's a couple of practice things here. If you feel you need more practice, you're not going to be graded on any of them. They're just going to be available in Canvas for you to do if you want the practice. So these are ones that Jason uploaded on here. I'm not sure what they look like. Yeah, I haven't published the rest of them yet. So, but like if you're watching my stream here, so like this is a sketch you can practice with. Um, there's a couple of those. We're gonna talk about design tables, which is kind of a cool way um to design parts. And so basically the design table is like it's like an Excel spreadsheet where all the information is stored. So like all your dimensions are stored and uh all your components are stored and all your features. So like say you have a pattern, each feature in that pattern is going to be stored in your design table and you can change something in your design table and it'll change that throughout the whole part. So like say you have dimension 1 stored in your design table and you decide to scale your part, um, like you want to make it times 3 the size. So you would change all your dimensions in your design table times 3, and it would automatically update the whole part for you instead of having to go in and change every individual dimension. Um, so those are kind of cool. We'll go into that later on. It helps you kind of make things faster and change things faster. And once you have a few design tables established, you can create parts really fast because you have like a bunch of components that you're going to use, but they're already in there, and you can just add them into your part, and it just makes things go a lot quicker. So another thing this quarter, the big goal for CAD 2, like the big end goal for all of you, is that you'll be ready to take this SolidWorks associate exam. And I took it after I took CAD 2, and I got the certificate. It's a fairly easy exam if you're ready for it, but the key is speed and accuracy. So the more practice you have with just designing part after part after part, the better off you'll be. Because um, you're gonna have to design some stuff on the exam. It's timed, and it's kind of similar to the tests I gave you guys last quarter, um, where like you have to design parts, then you have to find the mass properties, and you have to input those, and you have to answer questions about them. So here's the practice exam right here. I'll actually go ahead and publish this so you can all see it, but oh, it's not actually stored in there. It's just a, where is the exam? Thought it was in here. Maybe it's in quizzes? No. Mhm. Okay. Mhm. Yeah. So like if you make an assembly, you're asking like if you can mate the two parts and then unmate them so that they can move independently of each other, or so that you can. Mhm. Yeah, yeah. So there's different types of like ways that you can mate the parts. Sometimes when you're doing an assembly, you'll need to actually mate parts and then unmate them to get them in the right spot to in order to have it work the way you want. But then you have to remove the mate in order to get your assembly to move the way you want it to. So like um yeah, so yeah, I think I understand what you're asking. Like I'm pretty sure that is something that you can do. Like you can animate the assembly after the fact, but you're gonna have to like remove some of the some of the rules that you made for how the parts could move before. You're gonna have to remove those later so that it moves the way you want it to. So yeah, and then like with 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 your machines that you design, you might not necessarily want it to be animated as if it were real life, you know. So when you assemble your whole machine at the end of the quarter, when you've designed all your parts and put them all together and you turn in your assembly, you might not want it to be fully animated because you might want to show like how things are in their starting state, you know, or in their ending state, probably in their starting state because the ending state with most Rube Goldberg machines is that you have to set everything back up again. But yeah, so like when you 3D print things and then you know and you assemble it in real life, it's not going to work exactly the same as it does in the model. So it's kind of a perennial problem that design engineers run into all the time. Um, Actually, at my day job, um, I'm a technician, and our mechanical engineers, they design stuff and I put it together and I'm like, guys, this isn't going to work like this. And they're like, oh, well, it worked in the model. And it's kind of this running joke because it worked in the model means absolutely nothing. Things can work great in a model and not work in real life. So, and you'll probably find examples of that this quarter. But yeah. Mhm. So you're not going to need to be you're not going to need to be too concerned about it. Your tolerances will be pretty loose just because we don't have, you know, $2 million 3D printers and things aren't going to be super duper precise when you print it. You know, you're going to have rough edges and it's so your tolerances aren't going to be like in the thousandths of an inch or anything like that. I wouldn't worry about it too much. Yeah, I don't I don't know if I don't know if you want, you know, $1 million equipment, you should probably be going to tech school, but um so yeah, don't worry too much about the tolerances. You know, I would leave like a decent, so like if you have two gears that are interfacing, um you know, you would want to make the teeth slightly smaller than the gaps. And you might need to redesign and 3D print things again. You probably will several times. You know, um, yeah, yeah. So like if you design, you know, something and you've got a couple of gears, and they don't actually end up fitting together, and they don't work, you know, then you can redesign them and print them again. And that's gonna, you know, it's you're gonna have to experiment a little bit until everything works, but you'll kind of also figure it out after the first couple of things. I would like start simple with the stuff that you're doing for your machine. I would start fairly simple and you'll see like, okay, this 3D printer obviously isn't going to be able to say, you know, print like teeny tiny little gears. So I'm not going to bother doing those. But you'll kind of figure it out as we go along. So, mhm. Mhm. Yeah. Yeah. Yeah, that's a good point. So, that's something that it'll do is the 3D printer will say like it'll print a support structure because there's part of your part that's not supported. Um, and it's going to want to make sure that that cup doesn't just sink to the bottom and flop and cave in on itself. Um, so that's something to definitely be mindful of. A lot of the time, it'll print little support structures, and you'll be able to like cut those out afterwards with an X-Acto knife or something. Um, but yeah, definitely something to be aware of. Generally, with 3D printing, you want to use the biggest, flattest side as the bottom of your part, even if that means printing it upside down. So, like, if you want to print a table with four legs, you're going to print it upside down. You're not going to start at the base of the legs. You're going to start with the tabletop, and then the legs are going to kind of come up from there. Does that make sense? Okay. So, yeah. So when you design your part in CAD, you're going to have, on your, I guess your horizontal plane, you're going to have the bottom of your part, like, you might, like, after you draw the whole thing, you're going to want to flip it over, and change its relation to the origin so that the biggest, flattest part is on the bottom in your design. And we'll go over that too. Like once you guys design your first part and you turn it in, uh, we'll go over each of your assignments together. So the way it's probably going to work kind of is we're all going to meet for class, right? And you're all going to show up in here and you can all, you can all talk to each other in Discord and you can all brainstorm and figure stuff out. And I'm going to come in and individually like take each of you into my conference room channel and I'm gonna, and we're gonna go over the thing that you designed for that week. And we're gonna talk about like why is this gonna work? Why is it not gonna work? What should we change? And I'll go over it with you, and um, we'll come up with the best way to do it. So, and then obviously, if you're not able to be here for class, or like if you just have a question in between classes, you can always, you can talk to me during my lab time, or you can also, contact me. I'll try and get back to you during the week with any questions about how to design something for optimal 3D printing. Um, and then there was something else I was just thinking about. Oh, if you come in during class or lab time, that's also going to be really beneficial because it's make it just makes it a lot easier when you can work together. You can sketch out your machines together. Like you're gonna have to talk to the person in your group about you know the handoff section of your section. Um, so so you're definitely gonna have to work together a lot. But yeah. So the other thing too, like if you watch those videos, you don't necessarily all have to do the same thing as a team. As long as you have a handoff from each person to the next, you're gonna be coming up with your own section of the machine on your own. So, uh, and it's gonna do a bunch of different things. So you don't have to have like a cohesive overall like this machine is gonna start here and do this and end here. It's gonna be a bunch of random crap in there. So. It's gonna be it's you know it's supposed to be fun. It's not supposed to make a lot of sense. So oh totally. Yeah, totally. Yeah. So yeah, and I mean that's but that can be as simple as like say um you know uh trying to think like say I have a section and then Mike has a section and I say like, "Okay, Mike, I'm going to roll a marble down a hill." And Mike says, "Cool, I'm going to put a domino at the bottom." That's all your handoff really has to be like, and then Mike has to incorporate that domino falling over into his section, and all I have to worry about as far as the handoff is I need to make a ramp for my marble. So that can be all it is. It can be that simple. It can also be more complicated. I could say like I'm gonna have a lever holding a spring down and it's gonna release it and the spring is gonna pop up and it's gonna push an arm that swings out. And then you know, the arm is going to swing out and like Mike needs to harness the energy from that arm swinging somehow, and he's going to say like, "Okay, cool. I'm going to, you know, hang a string from the arm and when it swings, the string is going to pull open a gate and that's going to like do something. I don't know." So it can be as simple or as complicated as you want, but there's all kinds of examples. I would suggest like, watch a bunch of videos, find some find some ideas, and just run with it, like just whatever you come up with that makes sense. Oh, okay, well, saunter with it. Yeah. There you go. um cool. So um I found the file with this sample exam. So it's actually in files. It's a CSWA sample exam here. And it's a zip file and there's these files that are in there, but this PDF is the actual sample exam. So this is kind of what you're preparing yourself for with all your practice. And let's see. Mhm. Cool. Who's in your group? Mhm. Mhm. Cool. All right. Awesome. So if you guys want to if you want to like each sketch out your what you want to put in your section, you can just say like, you can either like try and draw it or you can just list the components, just say like um I don't know, lever is released and pops balloon and the air from the balloon blows a piece of paper over or something, and like just list out each stage, or you can try and draw each stage and show me a drawing, but I just kind of want to have an idea of the stages of your machine. um and let me see actually, because I want you guys to have an idea of what you're doing so you can design a part this week. I'm just trying to think if we have enough time, like, because I could also have you guys all come up with your plan this week and then like give me a write up of the whole plan. Um, and then next week design the part. So Yeah. Yeah, that might be easier because I think like the tricky thing is you know, trying to trying to talk during like the class period and I don't know, everybody's in the same, same channel here and we kind of all have to share the airspace. So let's actually do that. And so let's say this week's assignment is just going to be um and it's going to be an individual assignment. I think I'm going to have each of you turn it in individually. So what I want is basically just a quick write up. So at the beginning, maybe put who's in your group, and then put which stage of the group you are. Like, say you're, the first stage. Um, then you're gonna say like, these are my sections, and then I think since I'm giving you all week, I want to see like a quick sketch. You can just do pencil on paper or whatever, however you want to do it. Just some kind of visual of like your your stage. And keep in mind that it's going to be 8 total designed parts, plus as many acquired parts as you want. So, within reason, I guess. But 8, yeah. So 8 parts that you design and 3D print. Yeah. Yeah, pretty much. So no, for your section, so you're going to design 8 parts each person. Yeah. It's going to be 32 for the whole machine. Because you're just going to do one per week. Yeah. Yeah. So there's 4 people times 8 parts per person. So it's going to be 32 parts per machine that get 3D printed. Um, and you've got all quarters, so you're gonna design one per week. Um, and let's see. Yeah, so you're basically gonna design one part each week. You're gonna turn it in along with your justification for that part. Let's actually go to that. I was gonna show you guys the practice exam here, but I don't think I posted all of it. Let's see. I'm going to by the end of class, so don't worry. But all right. So this is your first justification, um, and this is what you're going to include in it. So it's going to be a Word document for each. So for each part you design, you're going to write this document. It's going to say how much material the part will use and how long it will take to print using the 3D printer. Um, what steps were taken to reduce print time and material usage. So for instance, if you're 3D printing a pretty big part, you can make it hollow on the inside, so it uses less material, and so it's quicker to print because every bit of material that the 3D printer has to lay down, takes a certain amount of time. So the less it has to work, obviously the quicker it is. I guess that's pretty obvious. Um, um, Actually, let me. I don't remember where we. Yeah, yeah. No, so you can get an estimated print time, but I think I'm trying to remember. Let me ask Jason about that because it's been a while since I used it. I don't remember if that's somewhere in SolidWorks or if it's like when you save the file. Um, I'm gonna have to get with Jason on and catch up again on the 3D printer. It's been like 2.5 years, so um, since I used ours. But Yeah, if you have one. Cool. Yeah. Yeah. So I'll get that. I'll get all those details. And I'll get that all to you guys by next week. This week, you're not going to worry about that at all. The assignment is just to come up with your machine and your plan. Um, and so and you don't have to turn in a justification this week because you're not designing a part yet. So I'm gonna get with Jason. We're gonna figure out all the specs on our 3D printer here at school. If you have one at home, you're totally welcome to use it. I do kind of, I want to, I guess, have an idea of how the part you're doing turns out and stuff. I want to be able, obviously I'm gonna want to see it. And I guess you're gonna have to bring it into school anyway to put your machine together with your teammates. So that's gonna be, yeah, I guess doesn't really matter either way. But yeah, if you have a 3D printer at home, then you can absolutely do that. Especially if you want to, if you want to test your design before you finalize it or whatever. Um, so, so I'm just showing you guys this so you kind of know what to expect for next week. But we'll figure out, and I'll let you know how to. I know it's easy. I just don't remember where to find like the material specs. Um, and like how long the print time is. From what I recall from last time I used this 3D printer here, was that you just find out when you plug in your, you plug in your flash drive and you go to print the file, is that it tells you like this is going to take 8 hours or whatever. Um, so we'll figure out if you can actually know that ahead of time or not. Um, so you're going to want to describe in your justification what makes the part suitable for printing over other fabrication methods. So, why this is a part that you designed to 3D print versus just acquiring it some other way. So, like, for example, if you have a whole bunch of dominoes lying around at home and you decide to design a bunch of dominoes and you just make a little rectangle, it's going to be hard to give me that justification for, like, you know, why this was a good idea to 3D print. Um, but so you're going to want to think about that. Like if you want to make some gears that are going to, that are going to spin or whatever, you can say like, well, the justification is that you know, these aren't something I can just go to the store and buy. Um, and you're 3D printing it because, well, okay, yeah, but I mean, it's not like I mean, whatever. You could probably find anything on Amazon at this point, so maybe that's not a great justification, you're right. But like, this I want this gear made to these particular specs. I want to 3D print it because it's the only way that I can ensure that it meets the specifications that I need for this section of the machine. Um, yeah, yeah, exactly. Or like I need a ramp that's exactly 1 foot long to give my marble enough momentum to knock over the domino at the end. And the ramp has to have exactly this depth of groove in it to hold the marble just right, and it has to be at exactly this pitch. So we're gonna, we're gonna 3D print it because that's the only way I can ensure that all those criteria are met. Um, so that's basically what your justification would be, and then of course you're gonna include in there 2 screenshots of your part. Um, so So that's going to be each time you design a part in SolidWorks, you're going to do that little write up. Um, and that's kind of. Um, so for the first assignment, what you're going to turn in is just your section. So you need to talk to your teammates about like the hands-off part of the section. Um, so like say you're in the middle, you're gonna have to talk to the person before you and the person after you and make sure that your beginning and end matches their end and beginning respectively. So that it's a continuous project. Um, yeah. No, that's fine. I mean, this is just so that you have a plan to start with. I don't want you to like feel like you're tied to it in any way. But this is so that next week, when I say, all right, design your first part, you can look at your section of your machine and say, okay, well, I want this and this to happen at the beginning, so I'm going to design this. I'm going to start with like these 2 pulleys and a belt. Well, you're not going to 3D print the belt, but you're going to say, I'm going to start with these 2 pulleys, and then I'm going to put in my acquire parts. I'm going to put this belt in there. You're going to whatever you decide it is, but yeah. So that way you know where to start next week, and you can move forward with it. It's basically just a general overview of like this is what I'm going to do. Um, hmm. You can. Okay. Yeah, yeah, I don't see any reason why not. If there's stuff that you've already covered in other classes and you want to incorporate that, then absolutely go for it. The only thing with like the hydraulics is that you have to be cognizant of the stuff that we have down there is pretty messy. So is getting a little bit of that oil gonna is it going to make other parts of your machine slick and not work the way you intended them? You're just, take things like that into consideration, or like if I'm hooking up air over here, is it gonna blow hard enough to like knock over something down the line that I don't want to knock over yet? So just take those things into account. But yeah, absolutely, I think that's fine. I would also say like if you haven't I imagine most of you have taken most of those classes at this point, but if you haven't taken a class, then don't incorporate those components. So like if cause I want you to actually be able to do something that works, and I don't want you to get in over your head and not be able to do it. So if you haven't taken hydraulics or pneumatics, don't try to add that stuff in. Just I think that's also kind of a loose, not super enforced policy anyway. Like, I don't know if you're supposed to be using equipment if you haven't already taken the class, but I don't think that's really relevant because I think most of you have taken that stuff. Yeah. Mhm. Yeah. Totally. Yeah. Mhm. Um, yeah. 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 Thanks, Mike. I didn't I was having a hard time really following what you were asking, but yeah, that's it's kind of, it's supposed to, like, you're supposed to do the first thing, like, in the video, I think they started by like pouring hydrogen peroxide into something, and after that, the whole machine does its thing without any intervention. And I think that's what you want. Yeah. So yeah, exactly. Yeah, that's the idea. So, and of course, things aren't going to work on the first try. Like, you might have your marble roll down your hill, just because I keep using this example, you have your marble roll down your hill and knock over the domino, and you might need to mess with it a whole bunch before it actually hits the domino, and then the domino actually hits the next thing and makes it go. So it's gonna be a lot of trial and error, um, and it's gonna be a lot of like designing parts and then having to redesign because they don't work quite the way you wanted. So but everything always works on the first try. Yeah, you'll probably have a whole machine designed by like next week, and I'll just be blown away. Be like, all right, cool, we're done for the quarter. Good job, guys. Um, yeah, I can. Yeah. Yeah. So I think does everybody kind of have a plan, and you're all cool with who you're working with for your homework? Okay. Well, yeah. I mean, I don't. You have a plan to come up with a plan this week, so you think you're going to be able to come up with something. Cool. Yeah. Yep. So and then the other team, I guess, is going to be uh, let's see. Yeah, Nick is the person who isn't able to make it. He works from 4 o'clock on. So yeah, that's right. So yeah, if you guys want to also get together and come up with your plan, so yeah, and feel free to message me if you have any questions during the week. I mean it's all relative, right? Yeah, there you go. Experienced. Um, what's Yeah. Anyway, so I think we'll call it. I do want to go over that practice exam thing real quick, just because that's kind of what you're going to be working toward all quarter. And I encourage you to take it when you get a chance. Where is the? It's You can take it as many times as you want. It's actually an exam, but obviously since it's in a PDF format, it's not like timed or anything. I'm just trying to scroll past all this baloney so I can. So there's a couple of test questions. So you're gonna want to like kind of study up on what things are called. Like this. Uh, so do you want to detail, broken out section, align section, just section? They're gonna ask stuff like that. They're gonna ask you to model this. So I would encourage you to actually, practice not just this, but like the all the drawings that are in that folder. Just practice, modeling stuff and getting it fully defined. Um, and then once you build it, they're gonna ask a few questions about it. So they're gonna ask about the mass. They're gonna tell you what material, obviously, because that affects the mass, and then they're gonna ask you, um, let's see. You're also gonna want to know how to do design tables, because that's gonna come in handy when you're changing these dimensions. So like they give you A, B, and where's C? I don't see C. But they're gonna tell you to put those to these values, and then they're going to ask you for the mass properties, and then they're going to say change those values to these numbers, and then they're going to ask for the mass again. Um, and that's going to be on the real exam too. There's going to be stuff where it's like change these values. So the easiest way to do that is to make a little design table, and you put in dimension A, dimension B, and here's dimension C. I guess it's the extrude depth. So that way, when you can just go into your design table, change them real quick, and find your new mass properties. It just saves time, and I mean, time is super important on this exam. Yeah, yeah. Um, what are these? Yeah, 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 yeah. So the real one is going to be very similar. It's going to So these are something else. We'll get to that, but they're going to give you a different part than this to design, but it's going to be similar in format and like in what you have to do. So you have to make sure that you're fully prepared to do whatever they're asking you to do on here. You're gonna make some configurations to it. You're gonna like cut out these sections basically, and then you're gonna change A, B, and C again. You're gonna give them the mass again. It looks like here you do a shell. Um, mhm. No, I mean, they don't tell you how to build it. They just tell you to build it. So, as long as your mass properties that you give them are correct, it doesn't matter how you went about getting to this point, as long as you get there. You don't even need to do the design table thing. It just saves you a little bit of time. So stuff like that. you're gonna learn how to do it, and you're gonna be like, oh, this is a lot easier, and you're gonna. So that's the only reason I'm suggesting it now, is I'm saying, once you've figured out design tables and you've worked with them a little bit, you're gonna be like, oh yeah, this is cool. I like this, and I'm gonna do it. But or you might not. You might decide it's easier to just do it the old-fashioned way. But yeah. Hmm. Hmm. Yeah, yeah. It might be a little more complex. It might be a little less complex. It's gonna be, something random that they give you. It's definitely gonna be similar in complexity. Um, they're not gonna throw you a total curveball or like put a trick question on there, because they want the people who passed this test to all basically have the same basic knowledge. That's Otherwise there would be no point in having a test. It'd be like the exam means nothing if everybody's got a different test. Hmm. Yeah. Hmm. Yeah. Yeah. Yeah, exactly. So yeah, I mean, it's gonna be similar to the practice exam. This certification, basically all it says is you know how to model parts in SolidWorks. It doesn't say, you're a SolidWorks wizard. It's not the hardest exam you can take. But it just says, you have a rudimentary knowledge. You can make stuff. If you sit down with SolidWorks in front of you, you're not going to be lost, basically. And employers like to see it. If you're going to have to use SolidWorks at all in your job, they're like, okay, this person's familiar. But yeah, yeah. But nobody's going to hire you to like design a high-rise building in Seattle from the ground up. Like, so that's yeah, yeah. I mean, you could do it in SolidWorks. Jason was just showing me over break. He's gonna build a new shed, and he submitted the stuff for the permit today, and he showed me he designs the entire shed in SolidWorks. Like every single 2x4 is in there. He said he spent like dozens of hours on it. So yeah. Yeah, so well, we're not gonna have like we're not I'm not gonna give you guys a lecture on this stuff. You kind of have the basics down. What we're gonna do, I mean, for your Rube Goldberg machine, you're gonna be designing parts, and you're gonna be practicing, and you're gonna be putting them into an assembly. And there's gonna be stuff that comes up, and if you guys have questions, or if there's something you're stuck on, we're gonna do a lecture on that thing. It's, if you say like, I really want to learn how to use this advanced mate in SolidWorks so that my assembly does this, we'll go over that for a while in class. Um, but as far as like the practice exam, that's not going to be a homework assignment. I mean, you're gonna want to look at it, but like, I'm not gonna make you take the practice exam. I'm not going to grade you on it. It's here for your own edification, so that when you take the real exam, if and when you take the real exam, that's also up to you, you know, but you'll be ready for it. Um, mhm. Um, yeah. Yeah. So, yeah, I mean, this class is going to be a little bit more self-directed than CAD 1, since you do already have some basic knowledge. And, you know, obviously, there will be refresher stuff, and there will be stuff like, you know, you'll have plenty of opportunities to do practice and stuff like that. Um, so let's see, but you know, it's gonna be more of like, okay, hey, I wanna have a couple of gears that are interfacing that turn in my machine. How do I go about doing that? How do I design a gear? How do I like, you know, make it so it's 3D printable? And we'll go over that stuff together. Like, I'm not gonna leave you hanging out, you know, to figure that out on your own. But at the same time, since you're all gonna be putting different parts into your, you know, into your machines, and I want you to have the freedom to kind of come up with the machine yourself. I'm not going to say, like, okay, let's spend this week on gears. Like, everybody's going to do this because, you know, say somebody else wants to focus on another thing. Um, you know, then, like, that's kind of why, you know, what we're going to do instead of like a super structured lecture is we're all going to get together for the class period. You know, you're going to ask me questions and I'm going to go over anything that you need review on or that you didn't learn how to use the first time around because it's a little more advanced. Um, you know, we'll go over that stuff and then I'll talk to you one on one about like the project you turned in last week. Does that make sense? Okay. So, yeah, I don't want to, you know, I don't want to say like um, you know, it's going to be like super structured because it's not, but you know, I think with the freedom, you're going to be able to learn more this way, having kind of like more of a, you know, because like, so for instance in CAD 1, what I saw a lot was like I'd give a project, I'd say like, here's a drawing, everybody draw this drawing, and everybody would struggle with it, or they'd, you know, they'd either get it super quick and be really easy, or they'd spend hours on it and they'd be like, why isn't this working, why isn't anything making sense? um and when I said like, okay, I want you all to like say design your own thing, people came up with some really cool stuff, you know. And uh, I think, you know, you tend to get a little more in depth when it's your own idea and your own thing that you get to do. So I kind of want to capitalize on that and hopefully give you guys the opportunity to, yeah, yeah, exactly, you know, stuff like that. Like, there were weeks when it was like, here's your assignment, do this, you know. And it was it was really cool though. Um, yeah, you know, and you probably learned a lot from it because you were like, you know, you're using different features that you wouldn't have normally. So, yeah, yeah. So that's, you know, that's cool, and like you get to um, kind of do your own research. But obviously, I'm always, you know, here for questions. Like, you're not paying for the class for nothing. So, but you know, you tend to learn a lot when you kind of have the freedom to just do your own thing and um, do your own research and figure stuff out on your own. So, Yeah. No, you totally do. Um, so before you do anything, does it still work? Because you should still be able to use, I talked to Jason about, here, I'm gonna actually input it now, about the license code you used last quarter, and he said it should be the same. He said that one should still work. So if so, check and make sure your SolidWorks is still working. If it is, great, leave it alone. If not, then oh really? Are you able to open like a new SolidWorks window? Huh. Yeah. It could be. There you go. Um, so so try and I guess try and open the SolidWorks software you have installed now. If it doesn't work, delete it and redo the download following these instructions and use this code right here. It's the same one as last quarter. So if you just downloaded it last quarter, you should be fine. But if you downloaded it like a couple quarters ago or whenever you took CAD 1, then you might need to redo it. Okay. Yeah, so you'll probably want to re-download with this code that is on the home page now. Um, Let me know if you have any trouble with it, but that should work. And yes. Mhm. Yeah. All right. Yeah, I mean, and however you guys want to do it, if you want to come here and sit in the computer lab during class, like that's fine. If you want to if you just want to stay home, that's fine too. And then on lab nights, like, yeah, I think Mike updated all of the computers. I'll double check with him, but I'm about positive he did update them all last quarter. So, yeah. 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 No, I hear that. I mean, I I definitely like I barely left my house in the last year, so other than work, but um well, there's a vaccine now, so what was that? Hmm. Well, mm, well, the vaccine probably won't either then in that case. But well, politics aside, I think let's call it for the day if everybody's comfortable. Everybody get with your group. Send me your plan. You can decide it now too. I don't mind. Yeah, no, you're good. Looks like Eduardo already went there, so. right, bye guys.